Welcome back to Groundhog Graphics. This is episode 7 of Programming in C. And in this episode, I want to discuss more about loops and things that we can do inside of loops, like break statement, continue statement, um, goto as an alternative to a for or a do while loop. So let's go ahead and get started with a new project. And we're going to select console application. And this is going to be a C program. And so 6. More about loops. Finish. So here we are. So in this episode, we're going to start talking about we're going to start with a break statement. And I'm going to show you, what we're going to do is we're going to break out of a loop. A break statement will break out of any loop. For loop or do while loop. It's an alternative way of breaking out of a loop before reaching that end of the loop. Let me show you. Let's make an integer a. Let's put for a equals 0. Let's go a less than 10, a plus plus. That'll increment a. And let's put printf %d for decimal, comma a, and let's put a break right here. Now let's go ahead and put a little space there. Let's go ahead and build this and run it. See the 0? That is as far as our loop made it because we had the break statement in after our printf statement. So as far as a got, 0, printf, and we broke right here with a break out of our loop. Now, you may be thinking to yourself that this is not terribly useful, and you're right, it is not, but it is to demonstrate how we can use break. What we can also do to make it more useful is we can make it a conditional break. And we can do that with an if statement. If a, or no, let's do if 5 equals a. So 5 equals a. And let's go ahead and execute it now. Build, run. So now we have 0, 1, 2, 3, 4, 5. Okay, so our for loop counted up to 5, and then our break statement exited out of our loop. Let's go ahead and put an escape sequence in here of a new line character with a \n, and let's go ahead and run it. And there you go, it's nice, now it's in a row. Alright, so the break statement works with whatever loop it is, well, the most inner loop, whatever loop it's currently in. Let me give you an example. Let's make another loop inside of our first for loop. Let's put integer b, and let's go down here and let's put for b equals 0, b less than 10, b plus plus. And let's go ahead and put another printf statement in here. Printf %d for decimal, our variable b, semicolon. Now let's go ahead and go if, let's go 8 equals b, and we'll go to break and go back up here. Let's space that out. That looks nicer. And then I want a to print first. So what I'm going to do is I'm going to copy this. Go control, actually we'll cut it. And we'll come up here and paste it. So now what happens, our for loop begins. We print a. Matter of fact, let me take the new line character out. We print a. We come down here to our next for loop, and b begins, initializes at 0. It's going to increment until it's greater than, or equal to 10, equal or greater than 10. Obviously, it would just be equal to 10 at this point. And we will have another printf statement here, %d, and when b equals 8, then what's going to happen is we're going to break. And when this break occurs, we're going to break out of the for loop for the b, but we're going to continue looping for the a. A will continue looping until 5 equals a. Then we will break out of this outer loop for a, and the program will terminate. Let's go ahead and build this and run it. It's probably not going to look really good, but that's okay. We can format it. Yep, there we go. So we have 0 here, and what do we got? 0, 0. Let me see what we got. Oh, here's our problem. So we have our 0 here. I wasn't seeing it. 0 here, and it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, and then it puts the 1 here. So let me correct our output so it looks a little bit clearer. So we will go and put right here. Down here, let's do a put character, and let's put in a new line sequence, \n. And what this will do is this will print a new line, so it'll kind of break this up a bit. Also, let's go up here to our %d, and let's format our decimal number. Let's format it for 3 digits. So no matter if we have 1 digit or 2 digits or 3 digits, it will print 3 spaces. It will fill the spaces with digits if it has them, or it will just print a space. This will help our formatting look cleaner. Let me show you. See? That looks a lot nicer than what we just looked at. So here is A. And A is 0, it's 1, it's 2, it's 3, it's 4, it's 5. Then we had our break. But in between, we had the B loop. And when the B loop was running, it was printing 0, 1, 2, 3, 4, 5, 6, 7, 8. And when it hit 8, it broke 2 with our break statement. And so it continued down. So we've got 0 through 8 and 0 through 5. So that's how that works. And what that does, as you see, this break statement doesn't reference any particular loop. It just breaks from the innermost loop that it is located in. And when it breaks out of this loop, then we come down here and it will break out of this outer loop. So let's go ahead now, and I want to show you how it works in a while loop. It's very similar. But let's go ahead and cut our code out of here, and let's place this into a function. Control X. And let's put this under void function 1. Void. So we are passing no parameters and we are returning no parameters. Now I will go ahead and hit Control V, and that way if we want to, we can come back to our code here. Now let's see. Let's go ahead and do integer A. This time let's initialize it to 0. While loop. So while 1, and we will go ahead and do printf %d \n, and we will do comma a ++. Ooh, what is that? That's something new, isn't it? Yes, it is. We can actually do an increment on our variable a inside of our printf statement. And this is something you will commonly see when you're programming in C. So we don't actually have to come down here and put a separate a++. We can do it all inside of our printf statement. Now, you notice up here our while loop is while 1. That means it is an infinite loop. It will always evaluate to true. It will always loop, and it will never exit. So we have to have some way to exit, and that's where break comes in. So if, let's say, 100 equals A, we will break. And put a printf in here. Oh no, let's not do that. Let's put string. output string, we broke out of our while loop with the break statement. Let's go ahead and build this, and let's run it. There we go. And we counted from 0 all the way down to 99. We broke out of our while loop with the break statement. So I'm going to go ahead and now I'm going to cut this out. We're going to put that down below and save it in a function just in case we want to come back to it. So Control X, cut that out, come down here, and we'll put void function2, void, not passing any parameters once again, and Control V, we'll paste that in there. Alright, so now let's go ahead and let's talk about the continue statement, which works the opposite of the break statement. So let's go integer a equals 0 for a equals 0. Doesn't hurt to reassign a. Let's see, a less than 10, a plus plus. Let's see here. So to use continue, let's see here, instead of like we did with the break, let's see, let's put printf %d escape sequence a semicolon. And now let's go ahead and put a continue statement in right before printf. So let's go ahead and compile this and watch what it does. And as you can see, it does nothing. It never executes our print statement. However, it does continue the loop. The loop is continued all the way from 0 to 10, but printf is never executed because continue from this moment on goes and just reiterates this loop once more. So it just continues reiterating, and everything below continue never gets executed. Now, once again, using continue like this is not of any real benefit, but we can use it in a conditional situation, just like we did with break. So let's see here. Let's go. Oh, let's do this. If 5 less than a, then let's go ahead and do continue. And better yet, let me change this so it makes seems a little better. A greater than 5. So let's go ahead and let's execute that. And we see we have 0 to 5. And it prints 0 to 5. But everything past that, it doesn't print. But the loop does finish. And we can prove that by coming down here, printf %d is the final value of a. \n, comma, a. And let's go ahead and build it, execute it. 10 is the final value of a. So we can see what continue does is continue just instantly causes the loop to reiterate, comes right back to the top, and never executes anything below it. Alright, so now let's go ahead and just move this code right on out of here, and I'll put it into function 3. Control X. Function 3. Void. Okay, so that's in function 3. Now, another thing that we do need to do, if we want to use these functions, I was surprised it didn't give me a warning about this. Maybe it did. No, it didn't. We need to have some prototypes for our functions. So we do Control C, and we come up above main. Control V, semicolon. This prototypes our function so that the compiler is aware of it when it's compiling. And I'm going to go ahead and Control V again, and I'm going to change this function to function 2. There we go. Now if we want to use function 1 again, all we have to do is go function 1, and let's watch it work. Compile. Return with a value in function. Oh, in our main function we have no return, so it's return 0. Guess I shouldn't have copied that out of it, or cut that out, and I did it right here. Since this function doesn't return anything, we don't have to worry about the return there. Okay, let's try this again. There we go. And let's run it. Yep, function 1 works. Now let's go ahead and do our function 2. And let's go ahead and compile, run, and there's our function 2. So now, let's see. That. Now let's take a look at a goto statement. This is something that everybody will tell you, don't ever use a goto statement in your C code. That's fine if that's what they say, but you can obviously do it if you need it. I rarely use a goto statement, but there are occasions that it works out to be advantageous. So, keep this in your mind that you may need to use it. Let's see. Let's go ahead and do. Let's make this my goto colon and semicolon. And let me go printf %d comma a. Let's put a new line in here. New line. Let's go up here and declare our variable integer a. And let's go down here and go to a semicolon. Or no, my goto. Sorry, we're going to the variable. My goto. There we go. And let's increment a once again, like we did in our other function, and function 2. And then let's go ahead and go if 10 equals a, and we will break. Actually, I've never tried to break in a goto. I don't think it'll work, but let's try it. Oh, statement not within loop or switch. Right, that doesn't work. So what we're going to do is we're going to go to end, and we're going to come down here and put end colon semicolon. Now let's try it. Okay, I've paused the video here because I have made a very terrible mistake, and I don't know if you've caught it or not, but if you notice, integer a at the very beginning has not been, it's been declared, but it has not been defined as any particular value. Therefore, integer a will represent a place in memory that could have any value in it. And by doing that, it could introduce a very serious bug in your code, and you have to be careful of that. Now, I didn't notice it when I was programming this, and luckily it just worked out, but it will not always be that case. So make sure when you declare your variable, you also assign it some kind of value. If you don't do that, and you don't assign it a value anywhere before you start using that variable, the value inside of it could be anything. So anyway, let's continue on. There we go. And let's run our program. Well, 0 through 9, it worked. So you see, we didn't even use a loop this time. What we did is we used a goto statement. If you've ever seen or programmed in BASIC, Basic works very much with gotos and go subs. So, but goto is a big thing in Basic and maybe some other languages. Typically not used in C. Don't make a habit of using this, but once in a while you may want to use it. It just may make sense, and feel free to do it. One thing that you have to remember is when you're making a label, when this goto is a label. When it goes to it, you remember put the colon, and then you have to put the semicolon after it. If you get rid of the semicolon right here, which is something that can be easily forgotten, we will probably get an error. Let me see. We didn't get an error. Interesting. Let's run it. Oh, and it worked. Now, I've seen in other compilers that does not work. Okay, so I'm surprised it does here, but make sure you put your semicolon after, because you could be dealing with a compiler that will not accept that. Maybe an older compiler, maybe newer compilers will accept it. So anyway, this concludes this video, and I hope you learned a little bit from it, and I will see you in the next one. Alright, I'll catch you later. Bye.